Solid-state batteries have long been regarded as a game-changing technology for electric vehicles. Meanwhile, Toyota's announcement of a breakthrough in efforts to improve solid-state battery technology is seen as the death knell for gasoline-powered cars, offering electric vehicles a range of up to 621 miles, with potential increases to 745 miles in the next few years. Despite numerous future benefits, the current reality shows that solid-state battery technology still faces many challenges, one of which is the growing superiority of Tesla's 4680 battery cells, over which Tesla holds a monopoly. Which will be the best choice for the development of all EV industry? What is the significance of the energy density and charging speed of Toyota's solid-state battery? With the ambition to create a battery that can fully replace traditional internal combustion engines, Toyota has been researching and is committed to improving energy density up to 500 watt-hours, which seems to be more than double that of the 4,680 cells. However, everything remains in the research phase until the end of 2025. If this becomes a reality, electric vehicles using Toyota's solid-state batteries could achieve a range of 621 miles, nearly double the 330 miles that current EVs allow on a single charge. Furthermore, Toyota has announced that next-generation EVs using the new solid-state batteries could reach a range of up to 745 miles. Clearly, solid-state batteries have the potential to dominate the market in the future compared to Tesla's 4680 cells, mainly due to their significantly superior energy density. Some industry experts have praised the long-anticipated solid-state battery as a potential solution to electric vehicle concerns such as charging time and driving range. However, when considering charging speed, one of the key factors determining the safety and convenience of EV use. Toyota's first solid-state battery is expected to charge up to 80% in just about 10 minutes. In comparison, the Tesla Model Y, with a driving range of 336 miles, achieves a fast charge in approximately 15 minutes. Additionally, the Cybertruck, which uses 4,680 cells, takes only 20 minutes to charge its 400-volt 4,680 battery system up to 60%, and 40 minutes to charge from 10% to 80% with a 123 kilowatt-hour battery pack. There is also the issue of solid-state battery lifespan. Many consumer products using solid-state technology may have a lifespan of only a few years, while people expect their cars to last for a decade or longer. Toyota has shared some detailed insights into the challenges of ensuring that solid-state batteries meet the brand's reputation for reliability and durability. A long-standing technical issue is that repeated charging and discharging of the battery can cause cracks to form between the anode, cathode, and solid electrolyte, which reduces the battery's performance. Meanwhile, Tesla's 4,680 battery is expected to have a lifespan of over 1 million miles, equivalent to 16 years of use with an average driving range of 40,000 miles per year, demonstrating exceptional long-term performance. If you are enjoying this content so far, make sure that you liked the video and join us for daily episodes by subscribing to Techno Creator channel. We always appreciate your support. Why has Toyota's breakthrough in solid-state batteries not yet been able to replace the 4,680 cells? It is undeniable that the competition in modern battery technology is becoming increasingly fierce, with cost being the primary factor for electric vehicle manufacturers to determine their direction and the product lines they will launch in the future, especially affordable models that meet market demands, such as the upcoming $25,000 EV. Battery costs typically account for around 30 to 40% of the total production cost of an electric vehicle, making this factor crucial for manufacturers who are striving to improve and reduce costs in every possible way. When comparing the costs of the two solid-state battery technologies that Toyota is preparing to produce and the 4,680 cells, the difference is striking. According to Japan's Science and Technology Agency, the production cost of solid-state batteries ranges from $430 to $2,500 per kilowatt-hour, which represents a significant barrier, making solid-state batteries not yet a perfect choice. The lowest price indicates it is 4 times the production cost of the 4,680 cells. As a result, solid-state batteries may be reserved for high-end, expensive electric vehicles. Tesla is making rapid progress with the production of 4,680 cells, announcing that they have produced 100 million 4,680 cells across all their factories. This update comes just over 3 months after the company reported a total of 50 million 4,680 cells produced. They seem to have achieved an impressive production rate of up to 495,000 cells per day. This will help the company reduce the cost of electric vehicle production in the future. With exponential growth, expected an additional 100 million cells within the next 3 months, and even more by 2025. What barriers have Toyota's solid-state batteries encountered? Unlike traditional lithium-ion batteries with liquid electrolytes, solid-state batteries require precise fabrication of solid electrolyte layers, involving complex synthesis methods and high-temperature processing. This complexity not only increases production costs, but also presents technical challenges in scaling up for mass production. Designing solid electrolyte materials with the right properties is another challenge. Researchers aim to balance ion conductivity, mechanical strength, thermal stability, and compatibility with electrode materials. Furthermore, scaling up production while maintaining the quality and consistency of materials presents additional challenges. Traditional manufacturing methods, such as powder pressing or sintering, may not be suitable for producing thin, defect-free electrolyte layers with high ion conductivity. Developing new manufacturing techniques, such as solution casting, self-assembly processes, or tape casting, requires overcoming technical barriers and ensuring reproducibility at a large scale. Another important aspect is establishing strong adhesion and chemical and electrochemical stability at the interfaces between the solid electrolyte and electrode materials. Safety concerns for solid-state batteries remain a significant barrier, particularly regarding exothermic side reactions between the anode and cathode. These reactions can generate substantial heat, potentially leading to thermal runaway, a condition where the temperature of the battery increases uncontrollably, causing fires that are difficult to extinguish. In practice, supplying too much power in a short period creates a harsh environment for the battery cells located in the undercarriage of electric vehicles. Overusing fast-charging technology can lead to a rapid decrease in battery lifespan and the quick formation of dendrite spikes, which can cause short circuits. Tesla's 4680 battery is highly regarded for its safety due to several design advantages, including the elimination of tab connections, which reduces the risk of short circuits and enhances the stability of the battery cells. A recent report from China indicates that Tesla plans to begin mass production of the highly anticipated and long-awaited full version of the 4680 battery cells. The full version of the 4680 cells is expected to be produced using Tesla's dry electrode manufacturing process. The 4680 cells in the current Cybertruck feature cheaper anodes and more expensive cathodes. According to reports, this is because the anodes in the 4680 cells used in the Cybertruck are produced using Tesla's dry electrode process, while the cathodes are purchased from suppliers such as LG and are thus produced using the more conventional wet electrode process. Dry cathodes are considered the most challenging component of the 4680 battery at present. Additionally, cathodes are believed to have the highest cost share within the battery itself, accounting for more than 35% of the total cost of the cell. It is important to note that Tesla's 4680 battery technology has undergone several years of development and evolution, giving it a strong foothold in the market. Completely replacing traditional lithium-ion batteries will take considerable time, so the next 10 years might be when battery technology truly needs to be revolutionized. Therefore, Toyota's solid-state batteries need to focus on achieving their goals and accelerating progress with the hope of becoming a game-changer. What are your thoughts on Toyota's solid-state batteries? How might this battery technology replace the 4,680 cells? Please share your opinion below. We hope to bring the best information to you. Please give a thumbs up if you like this. Join Techno Creator by subscribing and hit the bell icon so you will not miss out on any awesome videos. We value your feedback. Thanks for watching. Until then, stay safe and have fun.